Okay, should we start or?
Yeah, I think we should start. Uh, Hello, everyone. Good afternoon. I hope you can hear me well. So, my name is Vineet. I am AVP of Sales at Techlabs. So, I'll just give you a brief introduction to the company, and then also I will introduce the presenter for today's webinar. So, this will be a series of webinar focused on pSeven SaaS. pSeven SaaS is a company which is based in Toulouse, France. And pSeven SaaS used to be part of Airbus, but now it's a separate entity for some time. pSeven has a product which can help large organizations uh, integrate their engineering workflows, automate it, as well as democratize it, so that people can uh, efficiently automate a lot of complex engineering workflows across teams, across locations, uh, across disciplines. So I have Nina Moëllo with me. She is the presenter for today's webinar. Nina is based in Toulouse, France. She is an application engineer with pSeven SaaS. Nina has done her master's in aeronautical engineering, and she has also worked in North America and France on various aircraft design and other areas. Uh, and we also have Jeremy with us. Jeremy is the channel manager for uh, uh, entire channel of pSeven SaaS. So Jeremy looks after the global channel management role at pSeven. So with this, I will give you a brief introduction about Techlabs, just a couple of slides, and then, of course, Nina will take over as a presenter. So, so we are a listed company. And then we have offices across India. And of course, we have an office in Dubai as well. So we have four different distinct verticals. One is the CA in Engineering Solutions vertical, which I am leading. Then we have a power system vertical, semicon vertical, and cybersecurity vertical. Uh, so when it comes to CAE, we have solutions for various CAE challenges that people like to solve. Uh, for instance, we have structural mechanics, durability, we do durability, acoustics, NVH. We have then manufacturing solutions like welding, casting, forming, stamping. We have products for CFD and thermal, multi-body dynamics, virtual reality, crash and impact analysis. And today's focus is process integration, which is where we have pSeven. So we do both products as well as services. We are one of the biggest in terms of providing a complete solution to the defense sector in India. We also do work with the automotive sector. Um, of course, if you are in touch with me, I can get in touch with you and share all these details. But with this, I will stop sharing and then I will leave it to Nina to uh, take over today's agenda.
Thank you very much, Vineet. Thank you all for attending this webinar. So my name again is Nina, and I will lead this webinar for today. Let me share now this screen here. So I will start with a few introduction slides and then move on with the screen you have at the moment, which is a demonstration of what pSeven Enterprise is about. Okay, so first let's have a little introduction of the main capabilities and what we are providing. So like Vineet introduced, our company is based in Toulouse, mostly because it is originated from an Airbus research group. Now we are totally independent and we have employees worldwide. So of course the headquarters is still in Toulouse in France. but we are an international company, let's say. We also have a large customer base that I will just briefly present afterwards. And our sweet spot is on those three main points that you see here. So we started with the algorithm section about design space exploration, optimization, and also machine learning and AI for predictive models. So this comes from the Airbus roots, and now we are using this strong basis to deploy integration and automation together with collaborative platform, which is pSeven Enterprise. So I told you about some references that we have, so you have some of them here. The idea is not to go through every one of them, but just to see that we can cope with very diverse topics. But the common points between all of those references is that they use intensively simulation and high fidelity mathematics computations. So in order to help those companies to take the most benefits of their simulation and be competitive on their different markets, we are implementing pSeven and pSeven Enterprise. So regarding the needs, by speaking with customers and prospects, we encountered different challenges regarding the engineering teams, and four of them are, let's say, recurrent in our discussions. So the first one is the idea of fragmented processes. You know that during a simulation process or, let's say, product development process, you may have different tools to handle, so from CAD systems to CAE systems, sometimes even in-house software. And I'm not speaking about PLM and SPDM strategies as well. So most of our customers are facing some coordination difficulties because every one of those software is using, for example, different data formats. What about the versions of the software? You need experts to handle the software in the proper way. So it's quite difficult to coordinate. It also comes with the manual data transfer, which is my second point here. You see that a lot of time is actually wasted for engineers just to translate data from one tool to another. So let's say gather input data from Excel sheets and send all of that to the CAE system and then post-process the results. This takes a lot of time and it's not valuable time for a company because engineers are not made for copy-pasting, basically. If you encounter such product development cycle here, you may also face some hectic performances due to unreproducible results. Thing is, okay, maybe as method and tools department, you are providing some best methods to work with. But what if you have one engineer, for example, changing some code lines or not using the right version of the software or the model, then it mixes everything and the results are difficult to validate. And the last challenge is the shortage of experts, because if you want to ensure that your simulation process is validated, then most of the time everything falls into one person or let's say a little group of persons. And then what if this person of group is not available at the time or is already highly loaded? It may also increase the design time because of some shifts. So this is the point of this slide, for example, that most of the organizations, big organizations, are limited by expert capacity to develop new products. So you see on this diagram here that you may have a lot of designers or engineers requesting some data, some simulations, some iterations, and everything falls into one guy here. And you see, of course, it's quite visible here that if this key person is, for example, absent or doesn't have the time to produce all those results, then your project may be delayed. So, of course, for example, hiring can be a solution here, but it will just add capacity in a linear way and it will not change the operating model. So this is why our strategy here is to propose a solution where this expert or group of experts will capitalize their knowledge and formalize everything into a version visual workflow. So workflow is this block diagram that you see in the little here. I will explain later. So just by formalizing everything, the method is captured, version controlled also, and can be then scaled. So basically shared, for example, through little applications that you see here. And those apps are totally managed by the experts, but can be executed by anyone who has access to the app. So this way, all the consumers of the simulation can just execute the apps that are already prepared by the expert. So the expert doesn't need to execute everything on his side. And of course, this will bring a high value because then the entire organization have specific accesses to the apps, for example, or to specific parts of the software. And this platform, thanks to its server architecture, can be accessed through any browser. I just want to make things clear now. I'm speaking about server architecture. It means not a SaaS solution, but one solution that is deployed on each company's site. So you are mastering where you want to deploy the solution, and it totally fits with your confidentiality rules. So if you want to cut it from internet, for example, this is totally feasible. So by following this process, we are then proposing the pSeven Enterprise platform, which gathers the 4 pillars that I'm presenting here. So first is the collaborative server-based environment. So like I just told you, everything is done into one single platform in order to enable collaboration even during workflow creation. This is something unique on the market, but all your collaborators are working from the same platform and everything is standardized and formalized here. So you have full control on the methods that are created. The seamless integration of any kind of products, whether they are CAD, CAE, SPDM, PLM, in-house software. This is very easy. It's low code, so it's made to be done by engineers in order to enable more productivity gains. Then I introduced briefly those applications. So from a workflow like this one, you can just push it as a little app with very basic UI. So you don't need to be expert in development to do it. And this enables to share the expertise at scale and to democratize high expert simulation processes. Finally, to just close the loop, I told you that our story started with algorithms, and those algorithms are still present in our products. So you have access to industrial algorithms for optimization, machine learning, AI, uncertainty quantification as well. A lot of different techniques that are very useful in the engineering world. And it all comes with what is called smart selection here. I will have some words about it later. It basically helps the engineers to tune the algorithm without having the need to be an expert in mathematics. So by using this platform, we already extracted some productivity gains. So we have some success stories, for example, those ones in the energy and aerospace sectors. If you're interested in, we have some YouTube presentations as well on those use cases. But basically you see that the time reduction of the project and also of the design was highly reduced. So this idea is to, once again, bring productivity gains. The platform look and feel is this one. I will present it in details afterwards. But basically, the idea is to prepare those kind of workflows, so block diagrams, where every block is responsible for one single action. So just by looking at the workflow here, you have already an overview of what's the task behind. So just by looking at this one, for example, I can tell you that, okay, everything starts here, and then you have several branches. So the first one is CAD update to go for ANSYS mechanical, I suspect, execution. The second branch is more CFD with OpenFOAM, so open source software. And the third branch is about a machine learning model. Okay, so we need more details about what is this machine learning model doing. But basically, those three branches are controlled also by a design space exploration loop. So you see you have exchanges with this block to potentially perform optimization, for example, and in the end, extract a ready report from this workflow.
Yeah. So before you move to,
Sorry.
you're moving to, okay. I was
Yeah,
thinking I
please,
can.
Vinit.
Yeah. So I'm launching a brief poll. It will be online for about 15 seconds. I request you to participate and let us know if you are using any automation, democratization, integration platform right now. This will help us tune the webinar for you. Yeah. Last 10 seconds, please. Okay, I'm ending the poll now. Thank you.
Thank you, Vinit.
So I've just shared the results. So majority of them are currently not using any automation platform. Very few of them are using it, and very few of them are figuring it out. Yeah.
Okay, great. So it means you're on the right place. So creating those workflows like this one, for example, is seen as an orchestrator. Okay, so you may have, for example, on one side your software, whether they are in-house or commercial. And the idea of pSeven Enterprise is to enable creating some formalization workflows. So like this one, for example, to just bridge the gap between all of those software. So you see we are very open and not attached to any specific editor. So any kind of software can be basically integrated. And then we intend also to bridge the gap with, for example, SPDM or PLM platforms. This is not the topic of today, but I invite you to follow those webinar series because we'll have a dedicated session for PLM and SPDM connections. So all of that to bring automation and democratization. Once you have created one workflow, let's say basic workflow, you also have the ability to capture it in this multi-user environment. So to create basically multidisciplinary workflows. The idea is that every engineer or group of engineer can work on root level workflows and then share all of that to aggregate a bigger, let's say, master workflow. I told you about the algorithm we are proposing. So you have just a list here of the library and techniques that we enable. So different techniques for machine learning, design of experiments, optimization, and also uncertainty quantification. But the challenge here for engineers is to first choose the best algorithm and then tune it. And this is not accessible for most of the engineers. So this is why we are proposing smart selection. The idea is that the engineer just provides the problem description. So what are the inputs I'm considering? What I am looking for? Is it to minimize some output or just to predict some outputs, for example? Then just to select in which area we are. Is it machine learning, design of experiments, optimization, or uncertainty quantification? And based on those information, smart selection will choose the best suiting algorithm. It will also, at runtime, execute this technique and tune it in order to achieve the best results as possible. And then, of course, the user will get the results together with metrics on the performances. So once everything like that is gathered, I mean, workflows are constructed and potentially mathematical features are added. The engineers are able to push it, like I told you, as web applications, so like little calculators. The idea is to start with preparing an automated workflow. And you see my workflow has global inputs and global outputs here that pSeven is aware of and is then able to generate this kind of interface with one column for the parameters and one column for the results. So it's a very basic graphical interface to enable formalized simulations without the involvement of any developers, for example. Of course, you can customize this interface if you wish to, but there's no need. And finally, the global idea behind that is just to serve the engineering population. So to centralize all of those apps into what we call Apps Hub. So the workflows can be then pushed into this library of apps that you see here. And then engineers have access to the apps that are dedicated to them. Okay, so maybe this mechanical engineer has access to mechanical applications and the CFD engineer has access to CFD applications, let's say. You can also split it by projects if you wish to, depends on your roles. So this is guided democratization. Okay, so I've explained most of the main features of pSeven Enterprise, but I think the best is now to show you how it lives, let's say. So I will today present a multidisciplinary workflow that was created for suspension analysis in pSeven Enterprise. Okay, everything started, so it's an automotive company that's initiated this project. And they wanted to just put in common 3 different teams. First one is a team related to multi-body dynamics. So those guys were using Adams software. The second team is regarding stress and fatigue, so using ANSYS Workbench. And the third one is focused on driver comforts, and they are using MATLAB scripts to simulate all of that. So those guys were initially working, each of them on their own sections. But the thing is that team number 2 and 3 are dependent on team number 1. So this is what we decided to implement in the workflow, to have a workflow that is basically automating the multi-body dynamics execution and then passing the outputs automatically to the 2 other teams. Okay. Then we have a master workflow here that is able just to consider, for example, road profiles, driving scenario, and suspension parameters as high-level parameters to go through all of those analyses in order to output safety factors, all the analysis details, and also a ready report for managers, for example. Okay, so you see here that we have 3 blocks, and those blocks are of type workflow reference, meaning that they are making a dynamic link to another sub-study. Okay, so this is what I will present right now. Okay, so this is now my pSeven platform that you have on the screen at the moment. So you see I'm connected on a browser because our deployment is okay, internet open, but you can also totally decide to cut it. So through this link, I'm connected on my personal account, and what you see on the left, for example, are my personal projects. Okay. Then in the middle, I have a fast access to recently opened workflows. And what's interesting is that on the right, I have a dashboard with my current activities. So you see that some of my executions went wrong with the red dots, but most of them went fine. And at the moment, I don't have any execution running. Otherwise, I would have one blinking workflow here saying, hey, I'm alive. This is quite important because the executions are also done remotely. So you can decide to attach any kind of resources, Linux, Windows machines, HPC, but everything is managed by the server. So the user works in transparent mode. let me just, okay. So let's go for one workflow, which is called then car suspension design. You have it here. So this workflow was built thanks to our block library, which is available here. So if I show you this common library, you see we have different connectors. So for example, ANSYS tools. We also have ARAS, which is an SPDM tool that will be presented in next webinar. We have some block templates, so you can decide to create your own connector for in-house tools, for example. We have blocks also for mathematical integrations or just logics, so conditioning, looping, different parts, and more generic integration. So for example, this block here, program Linux, will execute any kind of program on a Linux machine. Okay. So once you have selected your block, for example, if I want to work with MATLAB, I can just drag and drop it on my workflow and then work with it. I will present you. So I just told you before that we are here working with different teams. So you say that my multi-body dynamics team was already integrated. I will make it bigger here. Okay, so I already embedded the workflow for multi-body dynamics. I can open it to see what's inside. So this is the workflow they created. Okay, if I go back, I also have the one for seat suspension. I can open it as well. Okay, this one is much more simple, but still automates basic steps. And I'm missing still the ANSYS workbench. Okay, I will remove this one, which was an example. And actually, you see that on my list of projects here, I have some projects that were shared, okay? So I can decide myself to share a project by clicking here. You see I have shared this project with two of my colleagues in read-only mode, meaning that they can just access the project and decide to launch it, but they cannot change what is inside. But I can change this access to read and write, meaning that this time we will be co-editor of the same workflow. So like you are working with Google Docs, for example, if I change this access to Victor and Victor wants to make some block changes, for example, I will see those changes live. So I have shared this workflow like that. And you see that in my list, I have an Axel Beam workflow that was shared with me. So I can open it and check it. And this Axel Beam is exactly the workflow I'm looking for. So it will, for example, here read some loads and trajectory from a previous analysis, then prepare the loads approximation to be used in ANSYS Workbench block, and in the end, compute everything to extract the fatigue results. When I presented the blocks, you have to know that if you double click on them, you should have, okay, it's opened here. We have some specific interfaces. So this one, for example, is for ANSYS Workbench. You see that I can just load my ANSYS Workbench project that was already prepared by the engineers. And pSeven extracts all the inputs and outputs of this project. Then the engineer just needs to select with which values he wants to work and validate the configuration. You will see that all those parameters are then exported and extracted, let's say, as communication ports. So then I can make some connections between blocks to pass some information to one parameter, and then also to extract those parameters like that. Okay, so then the value transfer is also totally automated and formalized. So if I go back to my main workflow, I told you that I'm missing this Axel Beam integration. So I will do it live with you. I have this Axel Beam in my library of workflows. So I will just tell here that I want to add a workflow reference. Okay, I will look for it in my files. So it is here, Axel Beam. Select it. Okay. All right, and then I have added this link to my Axel Beam workflow. Now I need to connect it with the other blocks just to ensure that the values are passed in the right way. So the first link is just to tell my multi-body dynamics. When it's done, you can continue with the Axel beam because all the values will be gathered directly inside pSeven platform. So I will just draw a link like this one and tell, okay, once you are done, you can go for the second one. Okay, and then the results of this Axel beam will be used by the report. So I'm also giving a link here. And because of naming convention, I can type autolink and it will recognize that my damage value needs to be shared. So I can select OK, right? And for user convenience, I also want to myself get this value of damage. So I will click once on this block and tell that my damage needs to be uplinked. Okay, meaning that I want to see this damage value from a user standpoint in my workflow. Okay, so you see that in just a few clicks, I have added a new analysis in my workflow, and you would have done the same if you want to add your new, I don't know, ANSYS or any other CAE integrations. So this is very easy. I told you about the sharing capabilities. So this is how we can aggregate different workflows. We also have this idea of work groups. So here I was in my personal work group, but I can change it to other ones to check different projects, for example. And those work groups can be also accessed by different people. So this is the role of the admin to manage all of that. And finally, I want to push this workflow as a little application. Okay, so I can select my car suspension design here in my list and just decide in a few clicks. You see app setup, publish. Okay, so I can also manage here in which workspace I will share it. So for now, it will be only for me because I'm still in development phase. I can give it some picture, name, description. You see that it's version controlled. So I can follow also the progress of my development phase and I can publish it. Okay, this publication is just taking a few seconds. And you remember I told you that this workflow takes just some parameters as inputs. So we have to give the compression and rebound scale factors together with a road profile and driving scenario, which is basically velocity, vibration dose. And just by giving those few parameters, pSeven will go through the entire workflow to give us the report and also acceleration root mean square, damage, and vibration dose. So this is exactly what we will recover in this apps hub section. Right, so apps hub is this collection of different apps that you have here. And my app that I just published is this one. So if I want to create a new run, I'm just selecting this button, and then I can give my parameters and ask for a run execution. This execution will then call the workflow in the back and execute my automated process. Now I can also get back to previously executed runs. So to open this one, for example, and I can have a look on which parameters were used, what are the resulting values. I also asked for some plots to be displayed. So this is totally dynamic. I can make some little, let's say, post-processing activities from there. And I also have access to the files. So for example, the report that was created, I can download it and then take a look. It's the first opening of the day. Microsoft needs to wake up. Okay. All right. Okay, here we are with the reports. So within this report, we have asked pSeven to tell who was the author of the workflow, when was it executed, with which road profile and velocity, and then we have gathered different plots here. So this one is quite basic, but of course you may understand that we can do much more complex ones with tables, plots, and everything related to the analysis. So this one is honestly ready to be shared with managers or any other simulation guys. The idea then behind those apps is that you can embed basically any kind of process, and you can then customize how is the app looking like. I want to draw your attention on this topic, for example, which is hybrid electrical vehicle analysis. And for this application, we just decided to add a bit more description. So this is just textual information about what is the workflow doing. So you have a little picture of the workflow, and same here, we were working with different teams. And it gives also some details about what are the parameters and outputs. So for example, the units that are required and so on. And what's very specific about this app is that it embeds a surrogate model, so predictive model, that is shown here, and that allows to have very fast predictions. So then the user is able to change the input values here just with the sliders, and this will live change and update the surrogate model outputs. So you can have a brief description and visualization of your results. If still you want to have high fidelity results, you can select the run button here to execute the finite elements model that is behind. So this way is also a way to embed like different fidelity of simulation inside an app, and then to customize your own interface. Okay, and all the apps can be gathered here. You also have access to different work groups. So for example, this public information means that it's published in the public work group. You see that this one is my own work group, so personal one. Then we have some examples and different groups for different behaviors and different apps. Okay, so this session was honestly just an introduction of what pSeven is capable of. I invite you also to answer the different questions Vinit may have for you, and to follow the next sessions, so next webinars, during which we will detail how to automate a workflow, so how to make some integrations, also how to collaborate with different users, so all those sharing capabilities and apps creation. We'll have dedicated session for SPDM and PLM strategies, and also a final one about digital twins, which is a very side topic, but totally enabled thanks to this server architecture. So thanks everyone, and I think Vinit has
thank you
homework.
For this quick introduction. And so I would like to now go back to the attendees that if you have any questions, please type your questions in the chat box so that we can answer it during the webinar. I have one more poll coming up, which I've just launched. It is about the challenges in your engineering workflows or engineering space. You can answer the poll. It will be live for 10 seconds. But in the meantime, if you have any question that you want to put up to the speaker or me, you can please do that. We will be taking about 4 or 5 questions before we end this webinar in the next 10 minutes here. You can please participate in the poll. I will be closing the poll in 10 seconds here. Yeah. Please do let us know by participating in the poll. I'm sharing the results of the poll. In the meantime, you can please type your questions in the chat box we will be taking questions now. Yeah. Got a question from. Yeah. Okay. If you don't have any questions right now, they are popping up. So I will launch the last poll, which is what would you like to do after this webinar? Would you like to receive more information, or would you like to take a demo or get in touch with the sales team or the pSeven team, or you can register your responses before I end this poll here.
Just maybe one comment on the answers we got from the previous poll. I saw a lot of challenges regarding standardization and automation of CAE processes. If you also want to describe your kind of CAE process you want to automate, this would be a good, let's say, first ground for us to start explaining how we would solve this kind of issue. You have seen that we have a lot of different connectors for different CAE solvers, for example. But if you didn't see your own program in this list, we are totally open to any kind of discussion.
Yeah, there is one question. The question is, could you please share case studies? Sure, I'll be sending the case studies to all the attendees. It will take about a week for me to formulate a case study relevant, and then I'll be sending it.
Yes, absolutely. I can share my slides and some information about the case.
Case study if you have it right now.
Sorry, I didn't get.
No, you were saying something. Sorry.
Yeah, I was saying that I will share my slides with you, Vinit, for sharing with participants.
Oh, sure. We will share that here. So if you have any questions, please do that. Otherwise, we will end the webinar in 2 minutes. Well, thanks for attending. It was lovely to see you all. I will create another webinar in about a month. See you then. Thank you.
Thank you all. Thank you, Vinit.
Thanks. Bye.
Bye. Bye, everyone.
Okay.